This video is for lesson 8.8, factoring by grouping. When you factor by grouping, what it is a method used to factor a polynomial with 4 terms by factoring a common monomial from a pair of terms and then looking for a common binomial, which means you have 2 terms. So factoring by grouping, okay? So you start with 4 terms, okay? We factor out a common monomial from a pair of terms, okay? So where this comes from is if we think about how we solve a regular multiplication problem, okay? So if I multiply this out, okay, first terms, change my color, 3x times x gives us 3x squared. Outsides, 3x times 2 gives us 6x. Insides give us negative 2x. And then negative 2 times positive 2, those last terms, give us negative 4. Okay? So if you look here, we have 1, 2, 3, 4 terms. And that's what we use this method for, so that we can factor by grouping. Kind of like if you think about that box method, or even the other factoring method, when we split that middle term into 2, but these ones are already going to have those 2 middle terms for us. Okay. So our steps for factoring by grouping. First, you have to make sure the problem is ordered by degree. Remember, your degree is your exponent. Okay, so you need to write it so that it goes from biggest exponent to smallest exponent. Okay, and then you split the problem into binomials. So you're going to have 2 terms here, split it, and 2 terms back here. Okay? Then you factor out a monomial from each set. So you're going to take these first 2, and you're going to divide these 2 by a number. Okay? You're going to take these last 2, and you're going to divide these 2 by a number, or a monomial. Okay? The monomials you factor out, okay, make one of your factors, and what's left over is your second set of factors. Now sometimes you're going to see that what you have in the parentheses are opposites. And if that happens, you have to factor out a negative 1 so that those 2 parentheses are exactly the same. Okay, they have to be exactly the same. And then our final step for these today is going to be to make sure that each set of factors is factored completely, because you might end up with one of your factors, one of your sets of parentheses, still being able to factor further. It might be that difference of squares. Okay? It might be the product of a sum or difference. Okay? So make sure you check that it is factored completely. Okay, so let's look at one of these. So here we have 8t to the 3rd power plus 14t squared plus 20t plus 35. Okay? So what I'm going to do is I'm going to split this right here in half. Okay? So that is splitting my terms into 1. Oops, and I guess I should have looked first. Does anything come out of all 4 of these terms? The first 3 are divisible by 2t, but 35 is not, so nothing is going to factor out. So right there, then I would split it into 2 like I did. Okay? And out of these first 2 terms, okay, I can divide both of those by 2, the 8 and the 14, and t cubed and t squared, the smallest exponent they have in common is t squared. So I'm going to factor out a 2t squared. Okay? Then I look at the last 2 terms. Okay, I have 20t plus 35, and those are both divisible by 5. Okay? So then what I do is the same type of math we were doing before. I'm going to take out that 2t squared from the first one. And what that leaves me with, 8 divided by 2 is 4. T to the 3rd minus t to the 2nd is just t. The t's cancel in the second term, and 14 divided by 2 is 7. Okay? Then I'm going to take out that 5, and that 5 was positive. So if I take 20 divided by 5, I have 4, and I still have the t, and 35 divided by 5 is 7. Okay? So what happens now is when I look at those parentheses, okay, 4t plus 7 is the same as 4t plus 7. Okay? So now I have my factors. Okay? So So my first factor is what I have outside of the parentheses. So the 2t squared plus 5 becomes one of my factors, and the other factor is what was left inside those parentheses. Okay? And then our final step is to make sure those are factored completely. So nothing goes into 2 and 5, they're not perfect squares, so that one's factored. If I check the second one, 4 is divisible by 2, but 7 is not, so that one is factored completely. Okay. So let's look at another one. Okay, I have 20r to the third power plus 8r squared plus 15r plus 6. Okay, if I look at those numbers, okay, the 20, oops, sorry about that. The 20, the 8, and the 6 are all divisible by 2, but the 15 isn't. 15 is divisible by 3, but the 8 and 20 aren't. Divisible by 5, but the 8 and 6 aren't. Okay, and only 3 of the terms have an r, so we can't factor anything out. So our first step is to split it, okay, since it's already by degree. Forgot to check that in the last one, but the last one was 2, okay, is to split it down the middle and separate our two sides. Okay, so if I look at this first side, 20 and 8 are both divisible by 4. My r's, my smallest power of r, is r to the second. Okay, when I look at that second half of the problem, the 15 and the 6 are both divisible by 3. Only the first one has an r, so I can't take out an r. Right? And some of you, and if you really like that box method, some of you might want to draw that box, okay, and put your terms in those boxes. So the first term here, the second term here, the third term here, and the last term here. And that might help you see that when you check these first two, we can factor out that 4r squared. When I check the last two, I can factor out a 3. And then we can still do that same method of what do I do to 4r squared to get to 20r cubed, is I multiply by 4 times 5 is 20, and I still need another r. And if I check that, 5 times 3 is 15r. 4 times 2 will give me the 8, and it's already r squared. And 3 times 2 gives me 6. Okay, so that's another option of how you can do that factoring work. Okay, whereas in that first one, we did it the parenthesis method from last week, Monday. And in this one, we did it the box method. Okay, I am going to finish this one out parentheses just so you can again see it both ways for the same problem. Okay, so if I go back here, and now I'm factoring out these first two terms by 4r squared. Okay, 20 divided by 4 is 5. R cubed minus r squared is just r. 8 divided by 4 is 2. And the r squared is already there. If I factor out the 3 from that second set, okay, 3 goes into 5, or 15 5 times, so I have 5r plus 2 times 3 is 6. So again, if I look at these factors, these two parentheses are the same. So my factors are 4r squared plus 3 times the quantity of 5r plus 2. Okay, the same thing I got in that box method. So whichever method you prefer, feel free to use. If that box makes more sense to you, makes your division easier, please do it that way. If the parenthesis method works good for you, then use the parentheses. Okay. Let's do some more. Okay. This first one. Okay, if I look at order of degree, we have 3, 2, 1, and none. If I look at my numbers, the first one doesn't have a number, so I can't factor anything out. Okay, so my first step is going to be to split it into those two problems. If I look at this first half of the problem, okay, what I can do is divide everything only by y squared. There's no number there that factors out. Right? If I look at the second part, they're only both divisible by 2. So when I factor out that y squared, right, y squared times y gives me y cubed. 7y squared divided by y squared is just 7. The second set, factoring out a positive 2, okay, 2y divided by 2 is just y, and 14 divided by 2 is 7. So we should again notice that our parentheses are the same, so we factored correctly, and I have y squared plus 2 times the quantity of y plus 7. Next one, and if you want to pause the video and try these next couple on your own before you watch them, that's perfectly fine too. Maybe be a good idea, right? So this next one, actually we have two variable terms. In the first one we have y's, right? But these last two terms also have an x, right? Which is perfectly acceptable for polynomials, right? So I'm going to start again by looking, does anything factor out? There's only a 2 in two of the terms, so I can't factor out a 2, right? And there's only a y in 3 of the terms, and an x in 2 of the terms, so nothing's going to factor out. So I'm going to split down the middle. Okay, out of this first side, only have a y in common, so I'm going to divide both of those by y. Second side, they both have an x in common, right? So this time I'm going to do that box method again, just to show you. Okay, you're completely your choice which one you do. Okay, so if I fill in my boxes, I have y squared, okay, and 2y. I have y to the x, and I have 2x. And we just said we're going to pull out a y, and we're going to pull out an x. So what I get when I factor these two, dividing by y times y is y squared. Y times 2 is 2y. X times y is yx. And 2 times x is 2x. So that makes my factors, these numbers outside my boxes. So for this problem, my factors are y plus 2 and y plus x. Okay, again, you can do that the grouping method, completely up to you. So we're going to do 3 more, and then we're going to look at a couple of harder ones actually. So first step, let's check, does anything factor out? First 3 have x's, x cubed doesn't have a number, so nothing's going to factor out. So I'm going to split them right there. The first set, I'm going to factor out an x squared. Second set, I'm going to factor out a 5. So I factor out my x squared times x gives me x cubed, and x squared times a negative 4 gives me the 4x squared. Okay. If I look at the second one, I pull out a positive 5. 5 times x will give me 5x, and negative 20 divided by 5 is negative 4. So if we look at that parenthesis method, okay, now if I look at those, my parentheses are the same. So my factors are x squared plus 5 and x minus 4. Right, now this one we still have a squared in there. Okay, if I look at those parentheses, we still have a number to the second power. And when that happens, you want to make sure you check for one of your simple rules from the last lesson where we had a power or a difference of squares. But since this one is an addition problem, right, it won't factor any further. So we are done. Okay. The next one is a little bit trickier. If you look at that, the very first step we said, remember, is to check if anything factors out. Okay, if we look at the numbers, only 3 of them have numbers, so nothing will there. The 48 doesn't have a number, so nothing there. But this one is not written by order of degree, so my first step is going to be to change that so it's written by order of degree. So I'm going to have n to the third power plus 8n squared plus 6n plus 48. So power of 3, power of 2, power of 1, and then no variables whatsoever. Okay, so next thing, separate that problem into 2 separate problems. Okay, in the first half, okay, don't have any numbers, but I can factor out an n squared. In the last half, both of these numbers are divisible by 6. Can't factor out an n because the second term doesn't have an n. So when I factor out my n squared times n gives me that n to the third power. 8n squared divided by n squared is just going to be 8 because the n squared was already there. Factoring out that positive 6 from the second set, 6 divided by 6 is 1, so I just have the n, and 48 divided by 6 is 8. So if I check my parentheses, okay, they're the same. So my factors are n squared plus 6 times the quantity of n plus 8. Again, this first one does have a square, but it's an addition problem, so that one is factored completely. Okay. 3 left. Okay. So same type of thing here. On this one, I would pause that video again and try this one on your own to see if you can get it. Okay. So first thing, anything factor out? No, because the first one doesn't have a number and the 12 doesn't have a variable. So I first, though, should realize that I have a 3 here and its 2 is way down here, so I need to rewrite it by order of degree. So I have x cubed minus 4x squared plus 3x minus 12. So we split that problem down the middle. Right? Those first 2 terms are divisible by x squared. The last 2 terms are only divisible by 3. When I factor out that x squared, x cubed divided by x squared is x, and the x squareds in the second terms cancel, so it's just minus 4. When I factor out that positive 3 in the second one, right, 3 divided by 3 is 1, so it's just x, and negative 12 divided by 3 is a negative 4. So if I again look at my parentheses, right, they are the same, which means my first factor is what's outside of those, so x squared plus 3. Again, that's a square, but it's an addition problem, so it's okay. And the second one is the x minus 4. Okay, so let's review those steps for factoring. Excuse me. Okay, so to factor a polynomial completely, you should try these steps. So this is a little bit shorter because it's taking each of those methods into separate accounts. Okay, so the first thing you do is factor out that greatest common monomial factor. If anything factors out, we do that first. Okay? Then we check your rules. Check those rules from lesson 8.7. Okay? See if there's any shortcuts you can take. Okay? That difference of a square, the product of a sum and a difference. Check if those work. Okay? We're looking for your shortcuts. Is really what that is. Okay? Then we factor out, if it's a trinomial, okay, we can factor it into those 2 terms, okay, which is really saying we can use either that box method, okay, or we might be using the X method, or we might be using the grouping method, okay, completely your choice. And the last one, if it has 4 terms, you have no choice but to factor by grouping. But even when you're grouping, remember you can make that box if you prefer that box method. So let's look at a couple more where we have an extra step. Okay? So what is the factored form of 6h to the 4th plus 9h cubed plus 12h squared plus 18h? The first thing you should notice is that all of these terms have an h in them. So we are going to know that it has to first be divisible by some type of monomial. And the smallest degree is just h to the first power, so we can factor out 1h for sure. But if I look at my numbers, we have a 6, a 9, a 12, and an 18. And I know that all of those numbers are divisible by 3. So for this problem, the very first step is going to be to factor out a 3h from all the terms. Right? So 6 divided by 3 is 2. H to the 4th divided by h gives me h to the 3rd. Right? 9 divided by 3 is 3. H cubed divided by h is h squared. 12 divided by 3 is 4. H squared divided by h is h. 18 divided by 3 is 6, and the h's both cancel. Okay? So what I have left now is still 1, 2, 3, 4 terms, which means my only option is to factor using that grouping method we learned today. So out of these first 2 terms, I can factor out an h squared. I can't factor out a number because 2 and 3 aren't divisible by anything. In the second set of numbers, I can only factor out a 2 because the first one has an h and the second one doesn't. Okay, so this one gets a little bit longer because if you remember, I already factored out a 3h, so I have to remember that's there. First part I factored out an h squared. When I do that, I'm left with 2h. Second part, okay, the 3h squared divided by h squared is just 3. Factoring out that positive 2 from the second set of terms, 4h divided by 2 gives me 2h, and 6 divided by 2 gives me 3. Right? So if I again check out those parentheses, they're the same. So what's outside is one of my factors, but here again need to remember I already factored out a 3h, so that's first. Then I write down those other two factors like we've been doing today, that h squared plus 2 and that 2h plus 3. Okay, if I again check this first set of terms, okay, it's h squared, but it again is an addition problem, so there's my final answer. So if I were you, I would again pause this video again and try this very last one on your own, okay, and then check it out, but completely your choice, okay? So in this last one, I'm starting with 60x cubed plus 34x squared plus 4x. So this one's only 3 terms. Okay, so what do I do first is still check if there's anything I can factor out. Okay, if I look at those numbers, they're all even, so I know they're divisible by 2. 4 would be the only other option, okay? But 34 for sure is not divisible by 4, so that's not going to work. And they all have an x in them, so I'm going to factor out a 2x first. So when I factor out a 2x, I am left with 30x squared plus 17x plus 2. Okay, now since this one's only 3 terms, the first thing you should check is if you have those perfect squares. 30 is not a perfect square, so we can't use any shortcuts. So now you need to decide which method you like. Okay, there is a leading coefficient, so that x method won't work. Okay, so we have to use either the box or that first factoring by grouped method. And I'm going to do the one where we kind of combine the 2 into 1. So I'm going to draw my box. First term goes here, which is 30x squared. Last term goes here. Okay, and if I think about my a and my c, a times c is going to be 30x squared times 2. Okay, so 30 times 2 is 60. So my numbers have to multiply together to get 60. Okay, and they have to add together to get a positive 17. Okay, if we think about it in that box method, remember these two squares have to total that 17x, that middle term. Okay, so what are two numbers that multiply together to get 60? Okay, so I know 10 and 6 multiply together to get 60, but they only add up to be 16. So I need to go something a little different. So if I think about 10 and 6 don't work, so let's try 5 and 12. 5 times 12 is 60, and 5 plus 12 is 17. So I know my factor is going to be 5 and 12, and since all my terms are positive, they're both going to be positive. So the last part is finding out where they go. If I put the 5 up here, then I have a 12 down here. Okay. If I put the 5x in the bottom, the 12x goes in the top. Okay. Your choice which way you start. I'm going to start by putting that 12x up here and the 5x down here. Okay. So when I do that, 30 and 12 are both divisible by 6. If I would have put the 5 up there, they wouldn't have been they would have only been divisible by 5, which in this one actually wouldn't have made a difference. Okay. So if I put 6, and then I know I can factor out an x. In the bottom ones, they have nothing in common, but that means I can always factor out a 1. So 6 times 5 gives me 30, and x times x gives me 30x squared. 5x times 1 gives me 5x, so that bottom box works. 6x times what is 12x. 6 times 2 is 12, and the x is already there, and 2 times 1 gives me 2. Okay, so my factors from my box method are 6x plus 1 and 5x plus 2, but I have to remember I already factored out that 2x, so I need that 1 out front. And since neither one of those have any exponents inside the parentheses, I know I'm factored completely